I am delighted to present our next speaker, Diana Morel. Diana Morel is a senior data scientist at Peloton working on creating value for the business from the product lifecycle. Diana has her bachelor's degree in mathematics and master's degree in operation research from Northeastern University. Her talk is entitled Introduction to Survival Analysis. Please welcome Diana.
Okay, great. So my presentation is called Intro to Survival Analysis, and I'll dig a little bit into what's going on here. So just a little bit about me. I'm a data scientist at Peloton, and I studied math and operations research at Northeastern University. I've included some pictures here of my favorite instructors. One of the coolest parts about working at Peloton is being able to take live classes in person for free. And if you don't know what Peloton is, I will absolutely explain that soon. Okay, so just to go over the content for this, we will go over an overview on survival analysis, a little bit on the concepts and the methodology. Then we'll do a tutorial using the Lifelines package and basically just understand how to visualize the big ideas. And then I'll talk through just a Peloton use case about like how I use survival analysis at work. Okay, so what is survival analysis? Survival analysis is a statistical tool to analyze time to event data. So this method models the probability of an event occurring as a function of time, or an additive measure. It doesn't necessarily just have to be time, and we'll talk more about this later. This can be used to estimate the mean time to an event or the impact of several variables on the likelihood of an event occurring. And this is just a valuable tool for understanding and predicting the time to an event of interest, and can have valuable insights for making informed decisions in a variety of fields, like I have at work. And to sum that up, survival analysis basically answers a question like, how long will it be until something happens? So like, how long will it be until a customer unsubscribes from our app? Not to be confused with something like a logistic regression, which will answer, will a customer unsubscribe or will an event happen, yes or no? So just to talk a little bit more about different applications in survival analysis. Historically, you've probably heard of this in kind of a clinical research or biomedical setting to estimate the lifespan of a population under certain conditions. So for example, when testing specific drugs, maybe you'll see a study where they're testing a cohort of people who are taking drug A versus drug B, and just understanding how long it takes before they have a reaction or until they die. So there are a lot of other ways that you can take that same situation and apply it to different scenarios. So for example, churn, where the event would be a subscriber cancels their subscription. Also, something like time to readmission after surgery, the event being the readmission. A situation where a car part is needed, so time until something fails on a car is related to equipment failure. And then also a fun example could be like time to adoption for a dog shelter. So how long does it take for a dog to get adopted? And so basically what I'm trying to show here is that events could be good or bad. And the idea with applying survival analysis is that you want to delay the bad events and speed up the good ones. So some typical questions for survival analysis. I guess survival analysis could also be described as a collection of questions, like what is the likelihood of survival? At what time is the riskiest for an event to happen? And what covariates affect that event or make it more likely? And so these questions can be transformed or characterized into real life or business questions. So for example, what is the likelihood of survival could be, used to answer how many subscribers will we have next month? Knowing, what time is the riskiest for an event to occur could also help with, answering what is the best time to run a promotion, and looking at what type of people are most likely to churn helps with looking at the different covariates or the different features that would lead to churn. So an important concept for survival analysis is censorship. And this is basically the situation where the time to an event of interest is not observed for all subjects in the study. So the event of interest could happen, could not happen within the study, or maybe a subject would drop out of the study. And so there are different types of censorship. One of them being left censorship, meaning that the event occurred before the study started, so you kind of lose that information. And then there's also right censorship, meaning that the event occurs after the study period. And so displayed here, you can see that those are the red dots. So this line here will show us if this is the time that we analyze the data, we'll notice that we kind of missed out on some information because the event happened after we did the analysis. Another concept is the survival function, and the survival function is the probability that the subject will survive past time t, or any time of interest. And as t ranges from 0 to infinity, or as time goes on, the survival function has a few properties, which we can see from the formula as well from this visual. So it's non-increasing at time t equals 0. No events have happened, so the survival is always 100%. We haven't had the opportunity to have any events happen. And then at time infinity, we should eventually see this curve or see the survival function go to 0. And so something like this will answer, what is the likelihood of survival, of course. But like you can see on the graph here, you can also answer the question like, what is the median time of survival for a certain population? Then we also have the hazard function. And this is the instantaneous rate at which events occur, given that no previous events have happened. And so the hazard function is the derivative of the survival function, given that it's the instantaneous rate. And modeling or showing the hazard function on a plot basically shows us the highest and lowest chances of an event to occur. And this is useful for finding periods of time that are the safest or riskiest for whatever it is that the event that you're looking at. And the question that this answers is, how likely is the event at time t? And then this leads us to the cumulative hazard, which is the total accumulated risk of experiencing the event as time passes. So what we can see here from the formula in the visualization here is that while the hazard function is that instantaneous rate and can increase or decrease over time, and maybe that's better seen here, this cumulative hazard can only increase or remain the same. Okay, so how do all of these relate? There's a reason why we went through all of these seemingly boring functions. But this is a great visual from the Lifelines website, which is a package that we'll be exploring in the tutorial, created by Cameron Davidson Pilon, and he's very active in creating this functionality and also updating it. There's really great documentation on there that I do recommend that everyone see. And this demonstrates the relationship between all the functions used to address survival function and how they relate to each other. So for example, the hazard function focuses on failing, whereas the survival function focuses on not failing. As you can see here, the PDF is the derivative of the CDF, and the CDF is the inverse of the survival function. So while we have these set of tools to answer these different questions related to survival analysis, we can also convert back and forth. Once we answer one question, we can convert to a different function to answer another way of looking at the survival analysis. Now I just want to talk a little bit about different methodologies that we'll look at in the tutorial. So the first one being the Kaplan-Meier estimate. And this is a non-parametric method. Non-parametric meaning that there's no distributional assumptions about the data. And this is used to estimate the probability of survival. So the probability of not experiencing the event of interest. And this is looked at as a function of time. And this estimate is calculated, for example, by dividing the number of patients who have not experienced the event of interest by the number of patients at risk at each time point. And the result of this is called the Kaplan-Meier curve, which we'll look at. And this can basically be used to compare survival between different groups and also estimate the median survival time. And so there are different assumptions with this. Censoring is independent of the likelihood of developing the event. Survival probabilities are comparable in participants who are recruited early and later in the study. So it doesn't matter when you join the study, your probability should be pretty comparable. And then the inputs for this, so when we think about how we want to use this and what is needed, you really just need a duration and an event, whether or not the event occurred or not for each subject. And so the pros of this method is that I think it's the easiest to apply and explain. It gives a really good overview of your data set, and it's great for just exploring the data. The cons to this are that it can't handle additional features besides these two inputs. So if you wanted to add any predictors or anything like that, that necessarily doesn't work with this. And because of that, the result can be biased because it's a univariate approach. So then a little bit more on this, on the curve, the estimate can be visualized on a curve or a set of curves. And the data input looks something like this. So a duration column, and then an event column, and that event column is just 0, the event hasn't happened yet, and 1, the event has happened, and this is when. And then this gets transformed into the estimate. So what you'll notice here is that for each time step or time interval, we'll calculate the survival probability. 0 is always 100%, no events have happened yet, so everyone is safe. And then as time goes on, we'll see, okay, now the survival probability is a little bit less because we have information here that people have experienced the event. And then this can be plotted on a curve or multiple curves. And I did say, you can't look at multiple or different slices of this. You can only have these two inputs. But what some people do is just plot the curves on top of each other so that you could compare different groups. Let's say compare different genders or something like that. And then another method that I wanted to talk about is the Cox proportional hazard. So this method is used to study the relationships between time and the event outcome and any predicting features. So here, finally, we get to kind of add more information or add more color to our data. And this is used to estimate the hazard ratio, which we talked about before. And this can use continuous and binary features to estimate the survival. So for example, with your duration and event, you can also add things like weight of your subjects or if you're looking at something retail related, the cost of something. For categorical features, you can look at gender, you can look at dog breed, basically just adding more information than we could before. And then there are a few assumptions here for fitting this model. There must be some independence of survival times between subjects. Subjects can't, depend on other subjects. The hazard ratio to subjects must be constant throughout. And then there's a multiplicative relationship between the predictors and the hazard. And this is something that we can see from looking at the formula. And then the pros to this is that we get to handle additional features. But then the cons to this is that maybe it's a little bit more difficult to explain. So there are many more methods besides these. These are just the ones that I wanted to focus on today on the tutorial. So just a summary of this, Kaplan-Meier can't use multiple predictors, although we could overlap curves. But if we were to do that for maybe a column that had many categories, it would be kind of difficult for us. So at that point, we might as well use the Cox proportional hazard. They both take time and the event of interest as inputs. Kaplan-Meier is non-parametric, and Cox proportional hazard is semi-parametric. And yeah, so let's get back to this slide about the tools and questions. Why did we just go over this? Okay, now we can see how a typical question in survival analysis could be transformed into a business question. And then we can use a tool from our toolbox on how to answer that question. So for example, for looking at the likelihood of survival, we have the survival function. For looking at what time is the riskiest, we look at the hazard function. For looking at, who is most likely to experience an event depending on their profile and any attributes, we can use a Cox proportional hazard. Okay, now we can go through the tutorial. Feel free to open the Colab link. I think everyone should have it. I can also resend it. Oh, it's in the chat. And the overview here is we're going to look at what inputs look like, what censorship looks like, basically just visualizing these ideas with the Lifeline Python package. It should be really easy to follow. Colab is Google's version of like Python notebooks. Don't worry, if you do anything on it, you won't be hurting my notebook. But if you want to change things, you should copy and save it to your drive. And it's already complete, so we can, if you want to, you can follow along. If you want to play around, you can do that too. Sorry, I'm just trying to open it. Option. Reshare. All right, so we'll just be going through this notebook. It's already completed, just for interest of time and just because we can't go in and help everyone if something goes wrong. But basically, the first thing that we'll look at is the Kaplan-Meier estimation. And I made this hypothetical example just to show you that you can use really any data set as an input for something like this. And so the data set that I made up was 12 dogs, and we wanted to analyze their life expectancies. And the necessary columns here are age and years for each dog and whether or not the dog has passed. This is kind of morbid, sorry. But yeah, so first we can make our data frame, call it dog life the first column will be the duration in years, and these durations are very not realistic. I just chose random numbers for the hypothetical example. And the event has to be 0, 1, a binary outcome. 0 has nothing has happened yet. 1, the event has occurred. And so what this looks like will be a data frame with 2 columns. For each subject, you'll see, okay, here at 4 years, this subject has experienced the event. And then you'll see something like this, 5 years, and the event has not happened. But at least we have evidence that at 5, this is like our lower bound. So that's why this information is still useful and we don't remove it. And so then we actually use the Lifelines package, and it's a complete survival analysis library written in pure Python, and it has incredible documentation. I added the link here for everyone. So then here we'll import the Kaplan-Meier fitter, and we'll use this to fit our hypothetical data to this model and see what functionality we can use here. So I want to set t time as my duration in this data frame, and then e as the event, whether or not it happened. And then you can fit the model like this. It takes in time and event. And the first function that we'll use is called survival function, and it basically organizes your data set by time and survival function estimate at each time. And you'll notice here kind of what we talked about before. When we run this for time 0, survival is always 100% or 1. And then as time goes on and we learn about the different events that happen or when events happen, that survival probability decreases. And then the package also has a way of getting the upper and lower confidence intervals. And this is great for explaining certainty. And so what you'll see here produces a data frame for the upper and lower bounds for your survival probability. And then what we also have is functionality to create an event table that basically tells you, hey, what's going on at each time interval and each time step. So it tells you basically what subjects were removed, which ones were censored, meaning that nothing has occurred, the event hasn't occurred for them, but we don't have any information past this point. And then the number of subjects entering the study, if they come in at different times, and then the number of subjects at risk for the event occurring. So you'll see starts at 12, starts at all of the 12 dogs, and then as the event happens, says, okay, at risk for this time interval, these are how many are left, and this is the population where it is possible for the event to happen to them. And so I'm showing you all this so that we can look at what the visualization looks like. So for example, we can plot the lifetimes, and what we'll see here is the survival probabilities as a function of time. And we get to see which ones are censored, which gives us like an overview of what is actually going on. So all of the blue lines are subjects or dogs that haven't experienced death yet. And then the ones that are red with the circle tells us, okay, at 4 years, this subject has passed. At this time frame, this subject has passed. And this is helpful because although we don't know when the event will occur for the blue lines or for the subjects represented by the blue lines, we at least have a lower bound that tells us, okay, this one has at least survived past year 3, and that gives us a lower bound to kind of predict in the future probabilities. And so then when we plot this, the survival function, we'll see what we just saw in table form, which is the survival function and then the upper and lower bounds. And so this is kind of confusing because this says, oh, this is a probability that an event hasn't happened, but we can look at basically the complement of this, the cumulative density function, which tells us the likelihood of an event happening. So this just goes back to show that you can convert back and forth to answer the different questions here. And then another great functionality that the package has is being able to basically, it's called predict, but what it does is it tells you for a certain time point that you pass, what is the probability of survival at that point. And so you can play around with this and change that to see at what timeline, what is the probability of surviving. Okay, so what if you wanted to compare the survival function across different breeds? So I did say that you can't really add additional information to this, but you can plot survival curves on top of each other to compare them. Okay, let's reconnect. I might have to rerun all of this. Oh no, we're good. So if we add a breed column and I just randomly decided what the breeds should be between Husky and Poodle, we can add this, adding more information to the data frame, and then plot the curves on top of each other. And then from this, we're able to compare and we're able to say, okay, at year 4, this blue line or the control group has a less likelihood of survival than the Husky group. And then as time goes on, they switch, and it kind of tells more of a story in terms of like comparing the different groups. And then the second part here is just going through the second method that we talked about, which is the Cox proportional hazard model. So what we're going to do here is fit the regression, plot the coefficients, and then see how one of the coefficients, what happens to the survival as things vary. So Lifelines has a few data sets already written out and ready for survival analysis, which is really great. I made up that hypothetical example, and you can kind of see, it worked for that, but that wouldn't necessarily work for the assumptions related to the Cox proportional hazard. So the data set that we're going to use is called Rossi, and this is just a data set with 432 convicts who were released from Maryland State Prison in the 1970s, and then they did a follow-up study for a year after they were released, where half of them were released and were assigned at random financial aid, and half of them didn't receive financial aid. So from this data set, we'll just look at, what are the additional features that were added to this data frame. So what we have here is we have the week after their release, whether they were arrested or not, whether or not they received that financial aid, the age at the time of release, their race, whether they had full-time work experience before the arrest, whether they're married or not, were they released on parole, yes or no, and then how many prior arrests that they had. And I just wanted to mention a little bit about pre-processing, because we did skip that step here. In order to fit this model, you have to have basically like dummy variables or one hot encode, the categorical variables, which luckily Lifelines did for us. So for fitting this regression, all we need is the data set. We need to tell it the duration column, which is week, and what our event column is, which is whether or not they were arrested. And then we can plot the hazard ratios. So that's something that we talked about a little bit, and how we look at this, or what this tells us basically, is the association between the predictor, the feature, and their survival. So a hazard ratio of 1 means a lack of association here. And a hazard ratio greater than 1 means an increased risk. And then anything below 1 is a smaller risk. So what we're looking at here from this plot is that race has an increase associated with an increased risk of the arrest happening. And then being married has that opposite effect. Whereas age here in the middle doesn't really have any effect. So you can see how this would help explain for other situations, what affects the likelihood of something happening. And then we can also pick just one and look at the partial effect of that outcome by looking at the plot that compares the baseline curve of the model versus what happens when one of these featured is varied and everything else stays the same. So we can look at how the survival function varies for whether or not they had, how many prior arrests they had. The survival function being the likelihood of the arrest, and this prio column being the number of prior arrests. So this takes in, okay, which feature do we want to look at and which values do we want to look at? And so what you'll see here is that the likelihood of not getting arrested at time t is greater for those who have less prior arrests. So this dark blue means 0, and it kind of goes on to this red. So the less prior arrests that you have, the likelihood that you don't experience this arrest after the study is greater. And then I'm just looking at time. I think I'm going to go back. And if we have more time, I can go through the tutorial more. But those were the two main things that I wanted to cover with the tutorial.
Wonderful. So we have,
sorry, is it already time for questions?
No, it's not, sorry.
Okay.
Go ahead.
Sorry, I just wanted to talk a little bit about how this relates to Peloton, and I can do that really quickly. Okay, so a little bit about survival analysis at Peloton. What is Peloton for people who don't know? Peloton is a hardware company. We sell stationary bikes, treadmills, rowers. So bikes that go nowhere. It's a subscription company, a content company. Classes are streamed live from our studio in New York and available on demand, and we're also an apparel company. So just this information to kind of get everyone to understand like the opportunities for this kind of analysis in the real world. So for my role, being in data at Peloton means learning from the members' experience to predict future outcomes and make recommendations that enhance the member experience. And given that Peloton uses technology and design to connect the world through fitness, I can just tell you a little bit about one of the examples. So now that we know a little bit about the business model at Peloton, there are just a few ways that we can get through this. So it's a subscription platform, has the best equipment, also has wellness content. And so you can see that there's opportunities to do this with engagement, looking at member churn. But the example that I'm going to focus on is hardware and predictive maintenance. So the use case for this is that imagine that we have a summary or a survival function for how members use their hardware for a certain cohort of people. So for example, if version X of Bike Plus has a probability of needing new pedals at 500 miles, I can then project that members who own this hardware and are approaching the same mileage will also need new pedals. And so in this case, it doesn't necessarily have to be a time function, but it's an additive function instead. So what this kind of looks like is the data input would be duration. In this case, mileage, which is an additive measure, doesn't necessarily have to be time. And then the event, whether or not they received new pedals. So 0 meaning that, okay, they've ridden 200 miles and they haven't requested or replaced their pedals yet. And then somebody who has ridden 100 miles and has received new pedals. So the time here being miles, the event being replacing your pedals, but then we can also add a bunch of different features. For looking at this. So for example, manufacture date, the different kinds of products that they might have, the number of shared users. Peloton is kind of like Netflix in the sense that you get to put different profiles for everybody in your home, and then the number of owners. So we have a refurbishment program, so you can buy a bike that was previously owned by somebody else and has been refurbished. And that could be an indicator on whether you need to replace your pedals sooner or later. So for forecasting, we learn new information as time passes and events keep occurring, that event being that members replace their pedals. And our survival function improves over time with more data, or at least it changes as we keep learning from everyone. And then monthly, we apply these survival probabilities to the appropriate cohorts. So if I know that people with a certain profile and fit this description, and I have the probability that, at 100 miles, they're this likely to need new pedals, we can make that association. And then what does censorship look like in this context? Remember that censorship is a situation where a subject drops out of a study or the event of interest takes place after or before the study. So that still happens in something like this, even though I'm not necessarily conducting a study. Selling your hardware, selling your bike could look like censorship. Upgrading your bike, there was a time where we let people upgrade from bike to Bike Plus, and that would simulate, someone leaving the study and introducing a new subject. Also, different products get introduced at different times. So we started out with bike, then we got tread, then row. So you can see how this censorship kind of happens in the real world as well. And then this impact, what is the impact of this on the business? So being able to forecast when members will experience an event with their hardware means that we can prepare with staffing and spare parts. And ultimately, this would save money, help us be a more data-driven company, and it gives members a better experience. And then the bottom line is that it makes fitness more accessible to everyone. So then the takeaway here is really that survival analysis is just a collection of questions, questions that could be answered with different functions, and they can be converted back and forth. And we've learned about the Lifelines package as well and how we can use it to explore or for EDA and better understand our data. And then we've also learned about how something that has historically been used in biomedicine in that context can also be used to translate to different ideas. And that's it. I'm happy to take any questions.
Thank you so much, Diana, for sharing your expertise with us today. And personally, I love learning about survival analysis. I know it's so essential in several statistical realms of research. So thank you. We have several questions, and thank you again for our audience for engaging. I'll start with one from the chat, and then maybe I'll continue with one that was sent to me. So from the Q&A, rather, we have one question that asks, how well will survival analysis work in the case of deciding the success or failure of the state of health for battery or cell life cycle?
Sure. I'm not super familiar with that context, but I think what's great about survival analysis is that maybe I don't necessarily have to be. I think that as long as you have an indicator for what is your time frame and what is the event that you're looking at or the event that you are expecting to happen, you can basically apply, what we've seen today to any kind of context.
Perfect. Another question I received is, how does survival analysis relate to machine learning?
Yeah, that's a great question. So how this relates, if machine learning is taking data and imitating how things are happening with humans and learning from that sense, survival analysis kind of does something similar where we're learning from past data to be able to project something in the future. And there is a lot of models that we didn't talk about today that are directly related to machine learning. So for example, there are models for random survival rates, which you can look into that kind of more directly does that. But I think it's related in the sense of, learning from historical data and being able to apply that to future.
Perfect. Great answer. So another question we have is, what methods can you use to deal with censorship due to variation in sampling time?
That is a great question. Variation in sampling time. So I'm assuming that means that subjects come in at different times. I think that in that case, we look at, we kind of normalize everyone's starting time at 0. So for example, in the censorship graph, even though people can come in and out of the study at different times, we want to normalize everybody's T0 to be the same.
Perfect. Another question asks, what are your suggestions for furthering your knowledge in survival analysis?
Yeah, for sure. I think that the best thing to do is look at examples online. Like the presenter before said, Kaggle is a great source. The Lifelines documentation is really great. And also, today we just looked at how to use that functionality and kind of just go through the different things that you can look at to kind of inspire you to understand what kind of questions that survival analysis can answer. But I think it's a great exercise to take those functions and practice in Python, like how to do them by hand. I think that would be a great way to understand what's going on, underneath the hood, even though maybe in practice you'll just plot it that way. But it's a really great way to really understand what's happening. And then there's another package that we didn't look at today, but it's called sklearn-survival. And that documentation is also really great.
Yeah, absolutely. Second to the documentation for that one. Let's see, Carla asks, for the input data, would you, for example, note whether each dog, going back to your example before, has experienced the event each year, or does each subject count for one time point as well?
Yeah, so we usually look at this as the event can only happen once in your lifetime, which is why death is such a used example, because it can only happen once for each subject. I think that if you want to look at when events that keep happening, you'll have to do conditional probability. What is the likelihood that the event will happen again, given that it's already happened? But in the example that we used, usually the event only happens once.
That makes sense. So Eric asks, what are some of the challenges you've met when using real-world data?
Yeah, that's a really great question. So I would say that for real world data, um, things aren't as clean as they are on the internet when you look at examples. And for example, the assumptions that we talked about could be violated. And so in that sense, you kind of have to do some trial and error to figure out, what is the best model to use when that's not the case. I feel like in using this at work, I've come across a lot of missing information, um, and having to decide, should I fill it in or should I not? So yeah, there are some challenges there.
Absolutely. And thank you again for our audience for putting all of your questions into the Q&A. This one is very interesting. The question asks, can survival analysis methodologies handle two opposing events? For example, a dog death and dog adoption.
That is a really cool question. Um, I haven't come across something like this, but I think that you can get creative and have these two events. So for example, how I described where if I'm looking at something where, I want to know if somebody has replaced their pedal, given that they've already replaced it, you can do some kind of calculation to organize that. But usually, I think for like EDA and for understanding, you usually use them separately. And I think that you can combine them to make a bigger story.
Wonderful. Another question asks, how well can you measure the performance of the survival model? Is it necessary to split the data into training and testing data?
Yeah, so for understanding how well it works, like for example, at work, for understanding, how well my model is working, I definitely look at, what has been the survival probability in the past, and then kind of withhold some information to see how is it working in the future or for a certain data set that I haven't tested on. But yeah, what you said is exactly right. That's exactly how you would do it.
Yeah, wonderful. Yeah, that makes sense. Perfect. Another question is, with the KM curve, how do you estimate the median survival if it doesn't cross the median point 0.5? For example, with the control versus husky KM curve, the control group did not reach 0.5. Is it just that you don't know what the median survival rate is, or is there some way to infer a median survival rate?
Yeah, this is a really great question, and it's actually a pretty big topic for what to do when your curve doesn't reach zero. Basically, what people say is like you shouldn't use it for that. Then you need more data. You need to collect more data, and you'll see that we only had 12 data points. And you wouldn't use that case for looking at the median, unfortunately.
One person says, thank you for the great session. Yeah, thank you. Again, does Peloton have data science opportunities in Canada?
I'm sure that they do. It doesn't hurt to look. Yeah, connect with me on LinkedIn, I guess.
Yeah, absolutely. And all of the speakers that we have here today are sharing their LinkedIn information. And so you can absolutely reach out or connect afterwards to investigate sort of different questions that you have. Let's see. So Asha asks, what are the main KPIs for analyzing the conversion rate for survival analysis?
Yeah, that's a great question, because when it comes to this survival function, because it ranges in time, it's hard to decide, what is the main number, the main metric that I should say. Generally, I would focus on a specific time. So I would say, across all of these products or across all of these different cohorts, the survival function at time t, and I'll pick one, is, this much, and that will be a great way to basically compare different groups and also make sure that you can give a standard number instead of always having to show a graph or always having to show a table that makes, that ranges from 100% to 0.
Yeah, absolutely. Let's see, Fiona asks, hi Diana, can you share some other models you've implemented beyond survival analysis when at Peloton?
Yeah, so we do a lot of different modeling at Peloton. Something else that we do is, like classification, deciding, I guess specifically for hardware, whether or not it can be refurbished or can be salvaged, deciding whether or not a hardware that gets returned is appropriate for being scrapped or appropriate for being used again, depending on all the features that are actually similar to the survival analysis as well. So that's a great question. And then I see one that says, can survival analysis be used to group mental health well-beings among ethnic groups? Yeah, I mean, if you have an event of interest, I don't see why not. Maybe the event of interest could be, seeing, getting help, maybe seeing a doctor or something like that, or maybe time to readmission. If you know that your patients are in a program, what is the time until they get readmitted? And then your covariate could be, or one of your features could be the different ethnic groups, for sure.
All right, I don't see any other questions at the moment unless folks want to enter some more into the Q&A, but thank you again, Diana. It's so clear and accessible content, just really a spectacular introduction.
Thank you so much. I really appreciate everyone.
Yeah, absolutely. Okay, and as I speak of it, someone asks, what is the day of the life like as a data scientist at Peloton? Yeah, walk us through.
Yeah, I guess for a day in the life at Peloton, I do want to mention that it's really fun and exciting because there are so many facets of the company. Like I shared how it's a hardware company and a subscription company and a content company. There are so many ways to get involved. And I think as a person of data, your opportunity there is to look for ways that you can apply what you've learned and make it happen there. So it's a lot of networking, socializing, understanding people's pain points, and getting creative with the data that you get to produce.
Excellent. One audience member is wondering what your favorite real-world data set is for practicing survival analysis. Yeah, you mentioned it's important to actually, experiment, try with, different data sets on your own.
I think there's a very popular data set on Kaggle for like telecom churn, which is really cool. So like understanding what plans people have in terms of their phone, and then seeing when they churn and seeing, do different plans are they associated with a different likelihood of churning? And I think that's a really great real world example that you could apply like anywhere. If you think of any subscription business these days, that's like really applicable.
Yeah, absolutely. Okay, so additional questions going once, going twice. Otherwise, we can take approximately a 5-minute break. Here we go. One anonymous member, I was wondering about this. Could you explain what churn means?
Okay, so sorry that I didn't explain this. But churn is basically for someone who has a subscription when you decide to cancel. So it means that you're no longer paying for the subscription. And it means that we've lost you as a customer.
Traders. I'm joking. Yeah. All right, excellent. Okay, well, Diana will be available to type answers to additional questions, and Oh, I appreciate this engagement so much. It feels like every time I'm about to say, oh, we can take a 5 minute break before the next speaker. No, folks are wondering and curious. Um, Asha asks, how do you decide between logistic regression and survival analysis?
Yeah, that's a great question. I think the rule of thumb for me is deciding, what is the question that you want to answer. So for logistic regression, because it's a binary outcome, I would ask myself, will the customer churn, yes or no, or will the event happen, yes or no? Whereas for survival analysis, I would ask myself, when will the customer churn or when will the event happen, which I think adds a little bit more color to the story.
Yeah, absolutely. You don't just have that binary response by asking when. And I mean, I guess logistic regression, it's at least in my experience, it's less intuitive to communicate, with the log odds. I see it with my students all the time. And communication is essential when we're trying to use our ideas in practice. So absolutely. Okay, well, I don't want to contradict myself, but maybe I encourage you. I love that there's so many questions in the Q&A, and also Diana will be here to type answers, and it's like that's the perfect phrase to have another one pop up. Wonderful. So we have one question that asks, how do you adjust your models after the pandemic started to improve accuracy? Um, and again, once we started to come out of it, Peloton shares surely reflect this change in the market.
Sure, I can answer that. So I guess for my use case, I use mileage as an additive measure instead of days, because we know that maybe during lockdown, people were inside more and working out more, and that doesn't necessarily reflect the change that happens on other days. So if I use days, maybe it doesn't necessarily reflect what has actually happened. But when I use mileage, I can meet people where they are depending on if they're in a season of working out a lot or if they're in a season of not working out as much. So it kind of normalizes that for us. That's great.
Yeah, yeah, absolutely. That makes a lot of sense. I didn't even sort of think about those complexities. Yeah, absolutely. All right, additional questions. We have 2 more minutes. Yay, nay? All right, well, I think for real this time, thank you again, Diana. Truly a wonderful presentation.